As we've seen, the consumer surplus as a measure of consumers' welfare captures both the income and the substitution effect. Where the substitution effect, though, doesn't actually account for the consumer being worse off. It's really the income effect that we want to capture. So we really need to make a more careful analysis of the situation to understand the effects of a price increase on the consumer's welfare. What we really want to know is the answer to the following question. How much money would I need to give you to keep you as happy as you were before the price increased? So what we're going to do is to use the expenditure function to answer that question. Remember that the expenditure function, E of P1, P2, and U bar, is the solution to expenditure minimization. So if you want to find the least amount of money that you will have to spend when the price of good 1 is P1, the price of good 2 is P2, and you want to have the utility level U bar, E of P1, P2, U bar tells you how much money you need to spend, the least amount of money you would have to spend. Loosely speaking, what it does is put a dollar value on this utility level U bar given these prices P1 and P2. So what does it cost you to get to this utility level at these prices? That's what the expenditure function tells us. So what this does is gives us a very nice measure of welfare. So it tells us how much utility U bar costs you before and after the price change. So let's say the price change for pizza is from P1 to P1 prime. Then what you can do is we can look at your change in welfare is what it costs you at the old prices minus what it costs you at the new prices. For example, let's suppose the price of good 1 is 1 and it increases to 10. Now let's suppose it costs you, before the price increase, it costs you $90 to reach utility level U bar. How much would we expect it to cost you to get to the same utility level after the price has increased from P1 to 10? Should it be smaller or larger? Well, I think we would obviously expect it to be larger. So let's suppose, for example, it was 10, it was 100. Then the change in welfare would be minus 10. It would be 90 minus 100, which is minus 10. So you have a negative change in welfare. The consumer is worse off. The negative sign always represents the consumer being worse off. But by how much are they worse off? They're worse off by $10. To get to the same utility level U bar, it would cost $10 more. Now the question is here, what utility level U bar should we use? Right, so we've got this equation here to measure your change in welfare is the cost of getting to the utility level U bar at the old prices minus the cost of getting to the same utility level at the new prices. But what should U bar be? We have two natural choices for this. One is the old prices. That's the utility level you were getting to before the price increase. And the second choice is the new utility level, the utility you get after the price goes up. What we're going to do is we're going to try both of these. We're going to use the first one to define one notion of consumer welfare, and we're going to use the second one to define an alternative notion of consumer welfare. Option 1 was to use the original utility level, so your utility level before the change in the price. So if we use the original utility level, U old, then the change in welfare that we're going to be measuring answers the following question. It says, what do I have to pay you for you to let me increase the price? In other words, it's the amount of money such that if I give you that amount of money and increase the price, you'd be indifferent between that situation and keeping the original amount of money that you had and not receiving any more money, but having the same prices as before. So we call this the compensating variation, right? So we call it the compensating variation because it's the amount of money that I would need to give you to compensate you for increasing the price. So the compensating variation is the expenditure to get to the original utility level at the old prices minus the expenditure to get the original utility level at the new prices. So if the price of good one goes up, then the compensating variation is going to be negative. This says you're going to be worse off. So what you need is, if we look at the absolute value of the compensating variation, if I give you that many dollars, that exactly compensates you for the increase in the price of good one or pizzas. So to repeat what I've said before, you would be indifferent between having the price rise and have me give you this many dollars, or having the status quo. Nothing changes. Those both situations, this situation and this situation, give you the same utility level. That's what the compensating variation tells us. So what is the quantity of money I would have to give you for you to be indifferent between those two scenarios? Option number 2 was to use the new utility level. When we use the new utility level, the measure of welfare answers the question, what would you pay me to prevent me from increasing the price? So what is the amount of money such that I could take away that money from you, or I could increase the price? You'd be indifferent between those two scenarios. We call this the equivalent variation because the amount of money that I take away from you, that penalty that you pay, is equivalent to facing the increase in the price. So the equivalent variation is the expenditure to get to the new utility level at the old prices minus the expenditure to get to the new utility level at the new prices. So it's the number of dollars that's equivalent to the price change. So your utility from having me steal this many dollars from you, so we look at the absolute value. So I steal this many dollars from you, or I raise the price of pizzas. One of the two. And you're going to be indifferent between the two scenarios. They both give you the same utility level. So if we calculate what that amount of money is, and that's what your equivalent variation. So the price increase and the penalty of EV are equivalent. So we've defined two notions of consumer welfare, compensating variation and equivalent variation. So let's look at both of these in an example. So let's suppose the price of good 2 is 1, and let's vary the price of good 1 and see what happens. Originally, you picked this bundle A, and you're on the indifference curve I1. Now let's suppose the price of good 1 goes up. So we have that the budget line rotates inwards from L1 to L2. So we have this new budget line, L2. Suppose from this new budget line, you picked bundle B, and you're on the indifference curve I2. Of course, because the price went up, you're going to be worse off. You move from a higher indifference curve to a lower indifference curve. The compensated variation is based on the idea that if I give you enough money, you would be able to get back to your original indifference curve. You're right now at the new prices, you're on the lower indifference curve, but if I give you more money, if I increase your budget, remember, as I give you more money, your budget line moves outwards. So if I give you more money, you'd be able to get back eventually to your original indifference curve. So what we're going to do is we're going to increase your income until you get back to your original indifference curve. So we're going to go from this budget line, L2, to this new budget line, LCV. Note that the slopes are the same. The slopes of these two budget lines are the same, but LCV is further out than L2. That's because we've given you extra money. Now the price of good 2, remember, we fixed it at 1, which means that if you spent all your money on good 2, then your income would be Y. If you spent all your money on good 2 after we've given you CV dollars, your income would be Y plus CV. So this distance is the absolute value of your compensating variation. Now, when you maximize your preference along this budget line, you pick the bundle C. Remember, we've given you enough, so we've chosen CV so that it's just enough so that when you pick your best bundle, it's on the indifference curve I1. So this distance here is the compensating variation. So that's graphically how you would represent the compensating variation. Now let's look at the equivalent variation. So let's go back to our original picture with the 2 budget lines and the 2 bundles A and B. And we are worse off when the price goes from P1 to P1 prime, causing the budget line to rotate in from L1 to L2. So the equivalent variation is based on the idea that if we take away money from you at these from L1, if we take away money, even when the prices were the same, that the original prices, you would eventually come back to this, drop down to this utility level that puts you on the indifference curve I2. So if I take away money, remember the slope of the budget line is not going to change. You're going to end up, as I take away more and more money, you end up with budget lines that are parallel to L1, but they're going to be lower than L1. If I take away just enough money, you're going to end up with a budget line LEV, so that the best bundle on this budget line LEV is going to be on the indifference curve I2. So you'd be indifferent between the bundle that you pick after the price went up or the bundle D when I've taken away EV dollars, but I didn't change the price. Remember, just like before, if you spend all of your money on good 2, because the price of good 2 is 1, then you would, at the original prices, you would have been able to purchase wide units of good 2. And after I've taken away EV dollars, when you have Y minus EV dollars left, you would be able to purchase exactly Y minus EV units of good 2. So this vertical distance between this point and this point is exactly EV. So that's a graphical illustration of what the compensating and equivalent variation look like.